Thanks everyone for tuning in. I know it's late there, but thank you so much for joining in. Quick introduction about me. So I'm Jayant. I've been part of Dell for the last 14 years now. And I work as a senior principal engineering technologist uh, I'm part of engineering, but extend out to sales and pre-sales in the APJ region. So, which means my part of my role involves doing the evangelism for the Microsoft Hybrid Cloud, and also enablement for our sales and pre-sales guys in the Asia Pacific region. Not just that, we are also, as part of the evangelism, we speak at various events and we showcase the capabilities of the product, the Microsoft Hybrid Cloud product, and all of that, right? So we do a lot of vlogging, blogging, and talking and everything. Not just that, we also take in a lot of feedbacks from customers and field and our partners, and take it back to our engineering. Work very closely with our engineering teams to ensure that the product is always kind of keeps on evolving over time, right? So that's a quick introduction about me. So this is going to be a demo heavy session, but just to kind of get the level setting, just to make sure that I set the scene. I just want to kind of introduce the Dell Technologies solutions for Microsoft HCI. All right, so now Dell has never been, it's not a new product, right? So we've been there in this landscape ever since 2016. Now, the Windows Server, those who are familiar with WSSD, which is called the Windows Server Storage Spaces Direct, so that existed a long time back, right, to 2016. So a lot of customers and partners today ask this question, right? So they seem to be a little apprehensive saying, Azure Stack HCI is a new operating system. No, it is not. In fact, it's evolved over time. So it's started from 2016, and it's continuously evolved ever since. So what you're seeing today is Azure Stack HCI is nothing but the stripped down version of Windows Server 2019. So 2019 exists even today. Now, one of the reasons why Microsoft kind of wanted to have a separate Azure Stack HCI operating system, which is now delivered as an Azure service, is one, to have a tight integration with Azure. Two, also have a better control over the launch and releases and the overall life cycle of the operating system so that they don't have to tie in with Windows Server releases. That's one of the things. Now, obviously, Dell being the number one HCI vendor today in the market, we command close to about 32.6% market share. That's according to IDC, according to last quarter. We are kind of, improving on that market share almost every quarter, right? So every year, every quarter, we keep that number going up. And even if you put the number 2 and number 3, it won't be still 32.6. With the Windows Server, we command, with the Azure Stack HCI and Windows Server HCI, we command close to about 40% market share. That's a significant number. These are all according to IDC numbers, by the way. So with the kind of, the expertise and the legacy of building this kind of HCI solutions for different vendors, right? So for example, VMware through VxRail, a single product stands at $6.5 billion business, right? It's just a single product. Now, with that kind of a expertise of building HCI solution, it was very obvious for Microsoft to partner with Dell, right? A very natural choice. So that's exactly what we are here to deliver for. So while others in the industry are trying to have their own kind of way to position Azure Stack HCI. Some go with reference architecture and so on. But this is something that we did long time back, right? In 2018 or something. So that's where we actually had the reference architecture. So, but right now we have completely gone away with that, right? Right now we are building a completely productized solution. So when I say productized, It's a similar approach which Microsoft took to build their Azure Stack HCI solution, which is the Azure Stack HCI operating system, so that they have better control of the product. Just like that, although the as you see, these nodes may look similar to, let's say, an AX 740, so let's say a PowerEdge server like a 740 XT or an 840 server or something, but they are rebranded as AX nodes. So much so that even the bezel has a logo that says Azure Stack HCI. Okay, so that means these nodes are purpose built to run Azure Stack HCI operating system, and these nodes cannot run any other operating system. Okay, so with the reference architecture, what happens is now they build a server, which is a standard, standard server that works with multiple operating system, right? The problem with that approach is that you are not going to be doing a continuous integration. You're just going to certify this on a particular version of the operating system and then be done with it, right? It's not a continuous integration effort. With Dell, we continuously integrate. When I say continuously integrate, what does that mean? Every quarter, Dell keeps on releasing newer versions of the firmware BIOS and everything. And not just that, Microsoft keeps releasing the monthly updates, cumulative updates, and then yearly updates. For example, recently Microsoft announced the newer version of the Azure Stack HCI operating system, which is 22H2. So all of these, as and when Microsoft keeps releasing, this gets tested by our engineering before it gets certified. So the advantage with that is now customers don't have to do this testing on their own. It's actually done by Dell and Microsoft cumulatively, right? So we kind of free up the customers so they can focus on their business goals as against worrying about, hey, am I running on the right firmware? Am I running on the right operating system? Am I running on the right version of the security update and so on and so forth, right? So that's the big baggage with that we're trying to reduce from customers. If you look at our portfolio, it's been pretty significant, right? So we have a wide portfolio to choose from, right from Intel options to AMDs, because AMDs today offer higher core density. And our performance architecture starts from anywhere between 25 gig to 100 gig. And one of the things that we really brag about is our integrated lifecycle management. So I will probably talk less on the slides and show you how it actually everything in action. Okay. Needless to say our global availability in terms of what's available. So this is in a nutshell what you get to order today. For instance, even now the 4 here stands for 14th generation. So which means even now we still sell 14th generation, but it's going to be soon end of sale. Okay, so which means we're no more going to be selling 14th generation. So it's only going to be the 15th generation. So from here onwards is all 15th generation. So 6515, it's an AMD. So if you see this, the last digit ending with 5, it indicates it's an AMD platform. So an AX75, it's a 2U server. It's a high density server with the AMD processor, right? So it can go up to 128 cores per socket. That means you can cumulatively have about 256 cores. Okay, because each server node comes with two sockets or 2 CPUs. And these are the Intel platforms because a lot of the customers may have standardized on Intel, so they want to go with Intel platforms. Any questions so far?
So far, no, then please continue.
Okay, so all right. So like I said, with 21H2, Microsoft introduced a lot of the security features like secured core, and then HCI, virtualization-based security, and all of that was introduced with 21H2. So what we did is made sure that our 15th generation servers, or whatever that you're seeing here, is compliant with 15th generation, not with 14th generation. That's one of the reasons why we always want to position a 15th generation server, because it comes with TPM 2.0 and all of that, right? So all the goodness that you see here, I'm going to be showing in my demo as well. Basically, the lock server configuration and firmware. So which means it gives the peace of mind to customers or the administrators any firmware update happens through Windows Admin Center under their purview, right? You cannot just initiate a firmware update through an unsigned binaries or even through a different method, right? It's completely a lockdown infrastructure. Secure arrays and secure boot, all of these today exist today in our traditional servers that we sell, which is the PowerEdge. We're trying to bring all those goodness to Azure Stack HCI as well. Okay. Now this is, Microsoft obviously recently started supporting a single node Azure Stack HCI, which means you can start from as minimal as just a single node and then grow up to all the way up to 16 nodes within a cluster. So we support a whole lot of network configuration. With single node, obviously, no, it does not even require a switch, but you can just hook it up to your corporate switch and then get it up and running. But the key thing to note here is we support anywhere between 2 to 4 nodes of switchless configuration. Now, what's a big deal about switchless configuration? Think about robo situations like a remote branch office or edge locations where they want to kind of minimally manage the entire infrastructure with no switching and all of that. It's very, very easy to just connect 2 servers back to back with 25 gig RDMA connections, and it reduces the overall footprint. Not just that, it's easier to manage as well, because most of the edge and robo kind of situations, we don't necessarily need, have a technically competent person to manage those clusters. So what they do is they hook up this cluster back to back, and there is a for internet connectivity and everything, they just connect it to their existing switch, and all of these edge locations are centrally managed from Windows Admin Center. Then for typical data center needs, we obviously have a scalable architecture through switching, which means they can start anywhere between 2 nodes and scale all the way up to 16 nodes within a cluster. So like I said, so I think, more than just selling the hardware, right? More than just saying, hey, you know what, I'm going to give you the best CPU in the market, the best memory in the market, the best storage in the market, right? So we've kind of grown out of that, right? So if you see our competitors, they keep saying, hey, we'll give you a lot of configurations and all of that, right? Now, one of the reasons why customers today trust Dell is the way we approach things, right? So it's not about, if you see the industry today, industry is, everybody is hopping onto public cloud. Why? Because they can use it as a consumption-based model, which means if all I need to do is consume it, pay for what I consume, and come out, right? But due to a number of reasons, for example, regulatory needs and so on, there are requirements where customers have to host their application and data on premises. But the bigger challenge for all these customers is, how do I manage my infrastructure? I don't want to get into the business of IT. That's their big challenge, right? Now, what we are trying to do, with Dell and Microsoft, is we're exactly trying to address that. We want to bring the cloud operating model to on-premises, so that's the reason why we have a completely engineered solution, which means you as a customer or a partner don't have to, manage when I say, test this infrastructure, whether it works or not. We want to make sure you spend as minimal time as possible on managing the infrastructure, but while we want you to focus on your business goals. That's exactly what we're trying to do. So if you see Dell, we have the greatest hardware, no doubt about it. But most of our talking is in terms of what's the value add that we are trying to bring in. What you're seeing on the screen is just one example of that. For example, the Dell hardware configuration policies. What if I told you that you can manage your Dell hardware configurations and compliance policies right from Azure portal using Azure policies, right? That's a game changer. I'm going to show you the video on how this is all done, right? So let's park this discussion when I actually try to do a live demo. But this is exactly what we are trying to achieve to the customers, right? Because customers would request. I mean, I talked to a lot of customers in all of APJ, right? All they want is, I want a single pane of glass to operate everything out of. This is exactly what we're trying to do. You manage everything today in public Azure portal. You can onboard the Azure Stack HCI cluster to on-premises using Azure portal. And just like that, you will obviously want to manage all your customers, all your organizational policies in Azure portal. What if I told you you can also manage your hardware policies right from Azure portal? That's exactly what this actually does. Okay. So moving on, so this is a security thing which we have brought in with 21H2. They've introduced the infrastructure lock is something that we're going to build in. The VBS, which is called the virtualization based security, was introduced. Secure core was introduced in 21H2. Kernel soft reboot is something that was introduced. So kernel soft reboot is basically, if you see 21H2 and initiate a reboot of that operating system, it operates almost 10 times faster than a 20H2 would actually reboot. So it's basically a faster reboot, right? So those are the things that we have actually incorporated even to our hardware. All right. Now, like I said, the hardware policies is something that we rave about. The other thing that we really want to kind of bring in is day one to day end operations using something known as CPU core management. So I'll probably talk less about it. So CPU core management today, I'll probably talk less about it on the slides and talk more about when I do the demo. But why is CPU core management so important? Because today Azure Stack HCI is built for customers on a per core licensing, on a per core based licensing, which means customers have to pay $10 US dollars 10 per physical core per month. And that's billed against their Azure subscription. Okay, most of you may be aware of that. Now, the problem is a lot of customers have voiced their opinion saying, hey, you sell me a 4-node cluster, and each of these nodes come with 24 core. Let's say I'm just giving an example, 24 core, and each node will have 2 CPUs, which means 48 physical cores. And let's say, for instance, they have 4 nodes. You multiply that by number of nodes, you get 192 physical cores. So end of the month, customer is going to get a bill of 1,920 US dollars. But what if the customer is not using all the physical cores? They may be using just 100 cores. So it's unfair to bill them for all the 192 cores, right? That's exactly what we're trying to address here. So what we're trying to do from Dell perspective, you can go tweak your physical cores and say, hey, I want to expose just 100 cores to Azure so that I get billed only $1,000 per month and not $1,920. Okay, I'll show you when we do the demo. So that's exactly what this talks about. Streamlined cluster node expansion, which means when customers starts today, let's say for instance 4 nodes, and tomorrow they can grow up to 16 nodes in a cluster, and tomorrow they want to add 2 additional nodes. So what we do is we bring in the compliance policies to ensure that the node is compatible to be part of the cluster. There are a lot of prerequisite checks before the node gets added to the cluster. That's exactly through the node expansion policies. We ensure that it has the right firmware, it has the right levels of the Azure Stack HCI operating system. It's added to the domain if it's a prerequisite. All of those prereq checks are made sure. For example, right? Maybe what if the processor is not compatible? Remember, in an Azure Stack HCI node, every node in the cluster has to be homogeneous in nature, which means this has to be the same generation of the processor and all of that, right? Although 21H2 introduced dynamic CPU, which is you can mix and match a CPU generations, but then a lot of customers' recommendation is to have same generation of CPUs. So what if the customer is trying to add a different processor, or a different memory configuration or a different storage in there? So we kind of make sure all of the HCI nodes that they're trying to add in is actually in compliance with the other nodes in the cluster. All right, so these are some nice things which I'll probably show you in the cluster in the live demo as well, instead of probably wasting time showing you the presentation. Now, the automated cluster creation is a big thing. Okay, why? Because think about the amount of time that is spent. So today, if you order systems from Dell, we tie in deployment services along with it. Okay, so which means along with the hardware, deployment services also goes with it. So which means we are responsible for deploying the cluster for you. Okay, so which means when a customer orders Dell, there's a Dell services queue that gets attached to it. Dell services personnel goes and deploys the cluster for them. The best part about it is, what if I tell you that overall deployment time is significantly reduced? That's exactly what the customer wants, because customer wants a lesser time for the cluster to stand up and be up and running so that they can deploy their workloads. That's exactly what we're trying to do. So each of our cluster nodes is pre-built in the factory with Azure Stack HCI operating system. Okay, so services don't have to spend time deploying the operating system, right? If it's single node, it's okay. Just imagine if it's 16 nodes, right? It takes a lot of time. So that's exactly what we're trying to achieve. And using an automated cluster creation, which gives you the ability to not only create a cluster, but also update all the subsequent firmware which are going to be on the nodes, which are going to be part of the cluster. That's the experience that we want to give to our customers. And then lifecycle management, right? Like I said, all that I'm trying to show you is not about hardware configuration, not about not about giving you the best memory and storage, right? It's all about value, differentiated value. Full stack lifecycle, clusterware update. Today the biggest challenges customers have today is not just updating, because Microsoft keeps releasing the cumulative update, quarterly update, and then yearly updates. Dell keeps releasing quarterly update, newer firmware and drivers, now and then, right? But that has to be updated without bringing down their production workloads, right? It has to be in a automated fashion. So what we are providing today is a single click clusterware update, which takes care of not only updating the firmware, but also the operating system in a single workflow, and absolutely no downtime. What we have seen is it significantly reduces the manual effort by close to about 88%. That's a significant reduction in the manual effort that is required to update all of these components. Imagine if you have to do this one node at a time. Okay, cluster monitoring, I'm going to show you in the live demo. So I think that's pretty much about it. One last thing that I want to show you is the support and deployment. Like I already spoke about, we have, when Dell sells the hardware to customers, it comes with pre-packaged services queue, which means we are responsible for deploying the cluster. And not just that, we offer a single source of support. So let's say tomorrow, if a customer has an issue with the cluster or with the hardware, they can either call Dell or call Microsoft. So internally, we have a ticket exchange system, which means without the customer having to call separately for a Microsoft issue or a Dell issue, respectively, right? So within our support system, we exchange the ticket. We have our agreement with Microsoft, so customers don't have to keep calling us over and over again. And we also have an autopilot, which means basically if there is a hardware issue, the ticket gets automatically created at the backend with our Dell support. And instead of customer calling Dell will actually call the customer saying, we have received an alert saying one of the drives have failed in your system. So we are arranging a technician to come and replace a particular drive or any hardware that's impacted. Okay, and then we have this Pro Support and Pro Support Plus, which is our support contract, and you can go up to starting from 3 years up to 5 years. These are Pro Deploy and Pro Deploy Plus. These are deployment options. With Pro Deploy Plus, you get 30 days of warranty, which means any issues that the customer faces within the 30 days of the services team is there to help them. Okay, but post 30 days, it goes back into Pro Support or Pro Support Plus. Yep. All right, so I think that's pretty much it. So with that, I'll probably go over to this. I hope everybody can see my screen here, right? Can everyone see the screen here, the Windows Admin Center?
Yes.
Okay,
Yes.
awesome. Okay, awesome. So this is your Windows Admin Center. If you see that it's deployed with 4 physical servers of AX6515, which I showed you. One of the options you get to choose from as far as the server is concerned. And one of the options that you see here is the Dell Open Managed Integration. What's that? Okay, Dell Open Managed Integration. So if I go here, you see the beauty, right? Well within the purview of Windows Admin Center, I get to manage my physical hardware. Okay, so today there are 4 nodes. If I go into the inventory of these systems, it says X node 1, 2, 3, and 4, and it says the model, the service tag of each of these things. It's AX6515. Now, if I go into these things, right, it gives me details in terms of what firmwares each of these things are running on, what CPU, what generations of CPU is currently running. If I click on the CPU, so it basically tells me what the CPU that's currently running. What's the memory that's deployed on these servers, right? You get complete nitty-gritties of each of the nodes. You can go into each of these nodes and drill down details into what's running. For example, physical disks. How many physical disks are running? What is the health of these physical disks? So you see the details that we go into basically to show what's available on your physical node. Just like that, you can go into each physical node and find out all those details. So iDRAC, those who do not know, iDRAC is basically it's called integrated Dell remote access controller. Okay, so basically you can launch a single console even when the server is down. You still have access to that server. You can power on, power off, and you can do many things with it, even update the firmware and everything. But you don't have to, because we provide you with a powerful tool within Windows Admin Center where you actually can go and update the firmware levels of the cluster. This is just to, for example, you may want to diagnose a server. You want to have a one-to-one mapping to find out what's happening with that server. In that case, you can just click on that server and then launch the iDRAC console. Okay, so security, as you can see, there's a red tag here. It says support processor type because AMD is not compliant with the 21H2 secured core. Okay, because 6515 is running on AMD, that's why you're seeing a bank here. But otherwise, all other security features are supported. Okay, and go into the show node level details, shows me the node level details of each of these servers as well. Okay, now coming back to the important point, update. So now you can do an update. So what does this update do, right? So this update is basically the firmware update for the nodes that are running in this cluster, right? Every quarter, Dell keeps on releasing the newer update. Now, if I click on compliance report, it's going to take about 5 to 6 minutes. So, but we'll see how quickly it does. But basically, what it's trying to do is it's trying to go back and fetch an inventory on each of the physical servers. Okay, compare that physical hardware inventory with online Dell update catalog. So Dell, what we keep doing at Dell is every quarter we release the newer, latest and the greatest versions of the firmware, the BIOS, the drivers, and everything. And that goes into, there is some issue with this, I think. Okay, we'll have to rerun this. Okay, but just to give you an idea, what this actually does is actually goes and collects that information right from that each of these servers and then brings that. So I have an interactive demo to show you how that actually works. Okay, so don't worry about it. But what this does is basically compares that information and then it tells you what's recommended, what's existing on the system, what's the current version of the firmware that's on the system, and then whether it's recommended to do an update or not. Okay, so then based on that, a system administrator can take a call and then proceed to update the firmware. Okay, so Azure policies, this is something that's exactly what I told, right? What if we today a lot of customers manage the entire infrastructure from an Azure portal, okay, including the Azure Stack HCI cluster. So what we have provided the flexibility for customers is also additionally they can, in addition to the Azure policies, like Azure policies today can check, hey, whether your operating system is running at the greatest and the latest and the greatest levels in terms of security updates or cumulative updates, right? It can check whether a particular port in your organization is allowed to be open or not. That all of those things that you can set in your Azure policies. Now, in addition to that, we're also providing compliance checks in terms of hardware, right? Whether security is enabled on this hardware, right? Whether a secure boot, for example, or let's say sys profile in your BIOS is enabled or not. I can check that. So what I will do is make sure that it runs that compliance against a baseline compliance, and it compares that. If there is a difference, it flags that compliance in Azure portal, which I'll show you in the demo. Okay. This is again the same thing. Now, this is the most important feature, right? So today, customers, like I talked about, customers don't want to pay for what they're not using in terms of physical cores. Okay, so this is where they can come. So today, if you look at this cluster, each node has 16 physical cores. Okay, now multiply that by number of cores, you're going to get total 64, total physical cores. So in this case, customer would get a bill of $640 US. All right. Now, what if they're not using all the physical cores? This is where I can change this, core count. This is cores per CCSD. That's a phenomena that has, applicable only for AMD platforms, right? So you can Google more around this, but this basically says that it's actually core chipset dice. Okay, it's per physical core. Okay, now you can actually control this. Now it comes to a total of 24 physical cores. So if the customer is using just 24 physical cores, then I can just go do this and apply this. But one thing to note here is that when you apply and reboot, if you have to do this manually, okay, you have to migrate the virtual machine running on that physical system on that particular node, evacuate that node, go into the BIOS, change this count, right, from 64 to 24, and then go back and then do this operation over and over again for all the remaining nodes. So what if I give you this flexibility within Windows Admin Center? Not just that, there is no downtime. It's automatic, and goes through the cluster aware update framework. Right, so I told you about cluster aware update framework, right, which basically is used here, basically to update our our clusters to the latest and greatest firmware. In the same workflow, even the update core count goes through the same workflow, right? So thereby there is absolutely no downtime for for the workloads that are running on the cluster. Okay, that's the thing that we are trying to provide here. Any questions so far?
So far, no. There's one from for Azure, and I think Noel has passed in some of the information for him already.
Okay, great. Okay, thanks, Noel. All right, so now, so one thing I wanted to show you is the interactive demo, right? So what we have done, because it's not really possible to have these demos up and running all the time, because one, sometimes the labs keep on destroying, recreating the lab. So that's why we have created something known as click-through demos. I've pasted that link here. Feel free to play around with it. It's actually very cool. So what it actually does is it gives you prompts on what you need to click and so on and so forth, just to get you a feel of how the Windows Admin Center plugin, which is called the Open Managed Windows Admin Center, would work. So if I just click on start and say Microsoft HCI Lifecycle Management and go into an option that is here, which is Dell online clusterware update, or maybe I can just go through this one-click full stack clusterware updating. Okay, let's click on that. All right, so it's collecting information. All right, so it says now check for updates. So as you can see, okay, as you can see, it's showing the Windows Admin Center. There is update screen. Under the update, you can actually do an update for both the operating system update and also the hardware update in a single workflow, right? That's the differentiator that we're trying to bring in. So it'll first now check for updates, and then it'll say, click for hardware updates, and I can click on that. And now it'll actually go and fetch the latest, a Dell Open Manage integration for Windows Admin Center. And if I click next, if you remember the last time, it didn't come up, right? So in this, it says now it tries and compares the versions that is running on the existing cluster, and then compares it to what's available online. And it shows, right? If something is, for example, in this case, BIOS is not compatible, or Mellanox firmware is not compatible. Okay, so if I click on next summary and say that I want to update this, download and update this, it'll just click on update and say yes. All right. So okay, so let's wait for that. All right, so now it's ready. It's downloaded all the updates that are available, and now it is ready to install those updates. Okay, so when you click on install, let's click on install. So it's now trying to apply those updates here. Okay, so a full stack clusterware update is actually being triggered right now. This is what I call a single click software update thing, right? So so if I want to show you I'll show you the other option where we have actually show you even from Windows failover cluster as to how even the virtual machines are automatically live migrating. Okay, so I think that's available here. So let's click on this one. All right, so right now the difference between that and this is, in the previous screen we had this update option here where you could go and update the hardware update and the Windows update in a single workflow. In this case, we are clicking on Dell Open Manage integration, which means when you click update here, it's only going to update the firmware of the hardware. Okay, so let's click this, and then so DRM is Dell Repository Manager, which means in this case they have selected offline update just to showcase that both online update and offline update also works. Offline is some customers don't want to connect to the internet. In that case, they can choose the offline update method as well. Okay, in that case, they would need something known as Dell Repository Manager, where it'll go in. So you can install a Dell Repository Manager on your laptop, download the catalog, and save that catalog in a share, and you provide that share details here. Okay, that's exactly what they're trying to do here. Right, and then click on save and go to advanced settings and select manually configure DSU. So that's basically I'm setting up all the the share details here. Okay, so so these things are, it would require some executables to be launched. That's why it asks you for DSU. DSU stands for Dell Server Update catalog. Okay, now it says test connection. This is basically testing the connection to your share. And once the connection is successful, and you save these settings and then go to compliance, just like an online update. Now all your repository is now offline. A repository is loaded. It shows you the compliance report as to what is compliant, what is not compliant, in terms of each of the each of these components. And then once you click on summary, and then you click on each of these nodes, and then schedule. So now a lot of customers may not want to run the update now. What they want to do is probably schedule this maybe on a Friday evening. So by the time they come back on Monday, they want to see all of their clusters are automatically updated. That's exactly what's the feature that we have provided, which means the ability to schedule the updates as well. Okay, and then this just to show, but we will, in this example, we'll just continue with running the update, immediately. Right. So now it's starting to run one by one. As you can see, this particular node, it's so let's go to the cluster Windows failover cluster. Okay, if you go to Windows failover cluster, you see this, right? The Dell AX6515 is draining. You see this, right? It's all done automatically, right? There is no manual intervention. Okay, and then you see the live migration of the VMs, right? So it's automatically live migrating. Okay, and then you go back. Let's go back to the node. Okay, if you see this, now it's installing the updates. Okay, while the second node is still waiting, second and third node are still waiting. If you go back here, and you see the node is down, and you go back to the Windows Admin Center, and it's running the update. Right. So think about it, right? So I'm just showing you what's happening, but in a real-time scenario, customers don't even have to open, Windows failover cluster, right? I'm just trying to show how this automatic live migration and draining of the nodes happen using Windows failover cluster. Yeah. So once you see two nodes are succeeded and third node is going through, and once that completes, it shows the compliance report, and then yeah, that's it. It's completely updated. Okay, so like that. So we have lot of scenarios as well. You can feel free to even dynamic CPU core management. Like I said, you can explore that as well yourself. In fact, it's a publicly accessible URL, so you should be able to play around with it. The one other option that I wanted to show you is the compliance. Okay, so there is a beautiful video here which was made. Let me share this link as well on the chat. So Mike Lamia, who is my counterpart from tech marketing team, created this video. It's available, again, it's available on public domain, so you can anyone can access that. So basically, he's kind of walking through as to how you set up this hardware configuration profile, so that you can actually create hardware configuration profile and arrive at compliance levels from Azure portal. So what you're seeing here right now is onboarded these AX nodes into public Azure, obviously, right? When you register, it shows up there, and it's going to show you what are some of the compliances that are currently available and everything. Okay, so I strongly suggest watch this video because he goes through narrating each of what this actually is. Okay, it's a fantastic video to kind of watch, but just wanted to kind of show you. So this is an Azure policy, and is kind of walking you through what are the various definitions that are available as default in public Azure, right? As you can see right now, there is no Dell policy. Okay, as a next step, what we're trying to do is we're going to onboard some of the Dell hardware policies into Azure policies. That's exactly what he is trying to do here. Okay, so one option is, now he goes into which we saw there. To let me maximize the screen. I think that'll be easier. Okay, so first thing is you sign into Azure, which is a prerequisite. Okay, so once you're signed in, once your gateway is registered with Azure, it automatically is signed into Azure. Okay, so once you're signed in, all right, so there is an option known as onboard checklist. Okay, so basically there is a bunch of checklists that you need to, it checks before you trigger onboarding of hardware configuration policies into Azure. It basically checks that the cluster needs to be registered, you need to have signed in as a user, and the user that you've registered, right, with the Azure AD credentials is all is all validated to ensure that you can actually onboard some of these into public Azure. Okay. Once that is done, you make sure that the cluster settings are intact. So you select the network topology based on the cluster that you deployed here. In this case, I think it's a fully converged network. It could be non-converged as well. Okay, so depending on how you're configured. Okay, so I think it's going to select the fully converged. Yes, correct. And once the deployment model is, it's a scalable architecture. Like I said, you can have scalable, switchless, or whatever that's available. These are all the cluster settings on where and how you have configured it. All right. So now, so it checks that cluster settings are configured, and now you're going to start onboarding the policies. Now, before you onboard the policies, it tells you what are the policies that will be onboarded to Azure. Okay. So this policy version today is 1.1, and what Dell will keep doing is keep releasing the newer versions of the policies as and when it is required. So as and when newer policies come in, it automatically says that there's a newer policy available, and it'll download that policy, and then it'll say, hey, here is the latest policy update that's available. Okay, so like you see, various things that are basically showing various hardware configuration policies as part of the HCI OS configuration policy and HCI cluster configuration policies, and all of these is like, will be onboarded to public Azure policy. Okay, so once you click on onboard, the policies will start onboarding. Now this is now going into public Azure. Okay, once the policies are onboarded, let's click on view details, and it shows you the status of onboarding. So it's everything seems to be success here, and you can export this as well into an Excel sheet if you want. Right? What are the policies that I onboarded as part of the tracking purposes? A lot of customers want to track what they've onboarded and everything, so they usually, you can save this as an Excel sheet as well. Right? Now we are in public Azure, and now you see the initiative definition type as initiative, and then you filter with Dell. You see the new policies show up, right? And these ones, the older ones that you're seeing here, the cluster is different. So which means for each cluster, you will have a different configuration policy. Naturally, right? Because not every cluster component has to be similar or of the same version. So that's the reason you will have different policy grouping for different clusters. So this is an older cluster where he's trying to show that, see, there are a number of policies. The number is totally different for this versus this. Okay, so this is a 7525, AX7525, which I showed you one of the server models. So for that, we are trying to, onboard that. All right. Now, if you go into the hardware configuration policies, you see all these policies that are onboarded, which are shown in the Windows Admin Center. Right. So all of that is actually now available with Azure policies now. Yeah. Then go forward. So, and then we will also check the compliance level at the Windows Admin Center. So we need to make sure what compliance level all of these hardware policies are actually at. So this is where for the existing cluster, that's what we are trying to do here. Okay, click on save and click on check compliance. It'll tell you what is compliant and what is not compliant. See, this is how beautiful, isn't it? If as an organization, I want to manage my cluster, and not only that, integrate my hardware policies with Azure policies. Very powerful way of doing this. So if you see that, right? So it basically, it says there are a number of compliance warnings, And if you go through the number of warnings, one that says not compliant, which is basically Dell hardware configuration policy, and we'll see what that is. So we can actually drill down into the details to see what that is. So this basically the Dell infrastructure lock policy, which means you need to go into the security to ensure, like I showed you in the security option under Dell Open Managed Integration, you need to go and enable Dell infrastructure lock. Since it's not enabled, it's partially compliant. That's why it's saying it's partially compliant, but it's a warning. Okay, if you click into the details, okay, you see now sys profile, it should have been performance optimized, but its current setting is performance per watt optimized OS. That means it's not the right configuration in the BIOS. Okay, so that's why it's complaining. And that's one of the reasons why it's not compliant. Okay, so we need to fix that. Okay, so let's see how to go fix that now. Okay, so what we'll do, we'll go into Azure and then go into those configuration policies as well, go into compliance, and just to make sure it's the same compliance even Azure policy is complaining about. This basically verifying that it's the same compliance which it's complaining. All right, let's pick one of the systems. As you can see, all three systems are not compliant with this particular thing. And if you click on details, it's the same, I think it's the same sys profile that's not compliant. Yeah, you see this sys profile must be set to performance optimized. That's what it's complaining. So from an administrator perspective, right, he does not even have to go into Windows Admin Center. Right from Azure portal, he gets to know what's compliant in his servers that's actually running on premises. You can either create a remediation task if you want to, but in this case, what we're trying to do here is we're trying to fix that compliance using Windows Admin Center. So like I said, this has to be done manually because you need to go here and set the security. So the security option here because we want to kind of give that leeway to customers, that handle to the customer as to how they want to set as part of the security settings as per their organizational policy. Okay, so the automatic is one that we want to show you as to how it can automatically fix that. Okay. Then let's click forward, basically explaining about what the difference between manual fixes and automatic fixes is. Okay, so now you can apply and reboot. Like I said, a cluster-aware update workflow is, we again fall back into our cluster-aware update workflow, just like how we did, how it did for the CPU core count management, even the hardware configuration profile fixing, which is basically it requires a reboot, right? So all of that goes through cluster-aware update workflow. Yeah, as you can see, each node has to be prepped. It has to be drained, live migrated, the virtual machines, and then it goes for restarting. While other nodes are waiting in the cluster. Okay, so one node is complete, and now it's trying to fix the compliance issue with the other node, and so on and so forth. Okay, let's fast forward. And now let's recheck the compliance just to make sure it's actually fixed it. And to cross verify, we will also go into public Azure and check the policies to make sure it's compliant. As you can see, it shows compliant here. See this? Dell hardware configuration policy is now compliant. Okay. Now the next step is to go check this in public Azure to make sure it reflects the same compliance policies as well. See everything is here. Let's go here and go to policies. For compliance, click on hardware configuration policy. Great. So if you go to policies now, everything says compliant. Okay, last time there's a ding there, shows red X. Okay, I think that's pretty much it, and you can export that compliance summary as part of your policies to make sure that you know what compliance that you pushed and so on and so forth. Cool. I think that's pretty much what I had to show. So in a nutshell, right? This is exactly what we want to deliver to our customers and our partners. It's not just about saying, hey, you know what? I am selling you a dumb box where you can have a lot of memory, a lot of processor, a lot of configuration that you want. It's not about that. And end of the day, you are responsible to manage. No, we want to kind of go away from that. We will sell you what's tested and working. So you as a customer and partner can focus on your business goals, not on the hardware infrastructure. So by automating all of this, like CPU core management, the hardware configuration policies, and all of that, like lifecycle management, like cluster aware update, seamless cluster aware update with absolutely zero downtime to your workloads. Okay. With that, I'll probably open it up for questions. I think it's probably good 5 minutes that we have. I know I had to show you a lot of things, but sorry, we just have 5 minutes for Q&A. I have a hard stop. Any questions?
Jayan.
Sorry, Ko?
Lots of good stuff. I mean, the Azure integration, I think is a very good update where we can actually monitor the compliance, right? And it becomes an object on the Azure Arc, right? While you're onboarding it to the Azure.
Yes, absolutely. It's a very, very compelling story. A lot of our customers love it.
That's really cool, man.
Yeah.
Hello, Jen.
Yes. Yes. Hi,
About
Joe.
this CPU core management, right? So if I update this CPU core, so is applied to all the 4 nodes, or I can do it single node by node, or how?
You cannot, right? You cannot change CPU core only for a single node. It has to be done for the entire nodes in that cluster, because remember, it needs to be homogeneous.
Okay, so if I update this one, so this just now I can see that I require to restart, right? So this restart will be how? Is a node by node restart, or is a
per node restart? So what it does is basically just like if you have seen that demo, a click-through demo of cluster aware update, right? As to how each node was rebooting and then changing that setting and all of that, right? The way we do it is we have something known as lifecycle controller through iDRAC. Okay, so lifecycle controller is responsible for doing programmatic way of updating core count or firmware update, anything. Okay, so or BIOS configuration changes, right? So in this case, it's a BIOS configuration change, which means I'm changing the core count of a physical server from, let's say, 16 cores to, let's say, 8 cores, right? If you have to do it manually, you have to live migrate VMs that are hosted on that node, evacuate the node, and reboot the node, go into the BIOS and change those cores, right? What we are doing is we are doing it programmatically using lifecycle controller.
Okay.
So we do it one node at a time. So one node, we change that, we bring it back to the cluster, then reshuffle the workloads, identify the next node, and then drain that node, change the CPU cores in that node, reboot, come back, add it back to the cluster, and so on and so forth.
And these feature actually even work in the data center edition as well as the Azure Stack HCI, the subscription edition.
Absolutely. It works with both Windows Server as well as Azure Stack HCI.
Okay, okay. Thanks very much.
Any other questions, thoughts?
So far, no.
Great. Cool. I think if there are no questions, probably we can call it a day.
Yeah.
Thank you, Jayan.
What a great sharing.
Very, very good session.
Thank you.
Thank you.
Thank you. Thank you.
There's
Thanks a lot.
a feedback form actually passed into the chat window. Feel free to share your feedback to us, especially to Jayan on the other topic that where he can actually enlightening and share with us more in the near future. All right, and see you in the next sharing session. All right, and thank you very much. Thanks for joining us. Good night.
Thank you. Thanks everyone for joining in.
Thank you. Take
Thank
care.
you.
Bye.
Take care. Bye-bye.